Hello, good morning, good afternoon, evening. Is Obidiki here, and in this video, I will explain how I went about the task solving, which is to write the word robot, as you can see on the screen here, on this piece of paper. And um, I first of all started by defining a point using the stitch pendant, and juggling it to the position which I want it to be. And doing that actually is going to take a very long period of time because, as you can see on my screen, I'm going to be having a lot of coordinates here, which generating all those coordinates is actually going to take me a lot of time to do. So I went ahead to write a rapid program here, which we actually, yeah, you can see I have just one generated point here, and then I have my code, which I use the offset and the move to write my various words like I want. Like you can see on the part here, I have the arrow B O T all written down as my subroutines. So in this video, in this task, the user of the robot has a choice of writing any alphabet he wants, or writing the full word robot his any amount of desired time he also wants to. So assuming the user decides that he wants to write the word O, the O don't necessarily have to be always be between B and T, or always have to be between R and B. The O can should always start at the beginning here where the arrow position is, or the user decides to write the word BOT. The B doesn't always have to start in the middle of the paper. It's the dimension or the position of the B should always start at the beginning of the paper and then move towards the left. So I'm going to first demonstrate it here to see. So first, I run down the simulation, and you see here it's asking us what exactly word we want to draw. You have the option of writing ROBO. Since O is repeated two times, we don't have an option for an O, but we have a W here. The W word is used to write if the operator selects it. He uses to write all the alphabets, write the full word robot. So I'm going to start with writing the letter O, and I'll just say I want to write it two times, and you see now it's going to start. It started actually from the home position, which is my robot target, which I actually initially defined as my robot target here. Instead of doing this using the constant, because when you use the constant, these positions are not going to change. It will always be arrow. If I write arrow, you can see here for arrow I have so many points to write just arrow, and arrow is always going to start at the beginning of the paper. At the beginning of the paper here, it will never change. And if I decide to write O is always going to be between arrow and B, which is also never going to change. So, and now I've also decided, okay, let's assume that the operator decides he or she wants to write the word T, and he decides to write the word T three times. So it's actually programmed so that the words will be written vertically. If it's a single word, it's going to be written vertically, and it's offset in the y direction, in the y axis. And now let's try to write the full word robot. Now we're going to pick W and say we're going to write the word three times like we saw earlier at the beginning of the video, and it's going to write the full word for us here, robot. So each letter was actually calculated using the size of the paper so that every word can fit into it. And initially, the task is to be able to write it three times. So the word was made to be bold enough to fit into the paper. Assuming we want to write it up to 4 times or 6 times, the word is actually going to be leaving the paper. So I'm going to stop the simulation here and try to run it again. To write the word O is going to actually have some stain or inks on paper. Write the word O, and so now let's write the word R 3 times or 4 times to show. And if the first one is written, the second one is written, the fourth one is actually going to be outside the paper. Why? Because the words were actually calculated using the paper itself.